All right, hey guys, I've gotten a lot of questions about the assignment from Monday and Tuesday, graphing piecewise functions. I had a pretty good office hours session with some folks yesterday, so I wanted to clear up a few things that are giving us trouble. Um, First of all, let's talk about like when we're looking at these domain restrictions, these inequalities. Okay, um, remember they're only describing the x values of the points that you're graphing. So anytime we're graphing a line, all a line is a bunch of points, and these are telling you where those points are going to be located, right? So this top line is only going to exist for x values that are less than or equal to -4. So I've talked about how we want to start by using that endpoint. Someone also pointed out to me they're a little confused by the vocabulary I'm using with that. You could think of it as a starting point, not an end point. That doesn't really matter. But the idea is we do need to plug this value in, and when we do, um, in this case, we get 2 times -4 is -8, plus 5 is -3. So we know that there's this point -4, -3. And I think most of us feel pretty good about how to determine whether that's an open circle or a closed circle, right? We're looking at whether or not there is an or equal to sign there, and there is. So it's going to be closed every time that there's a line underneath the inequality, right? So what this means is we can plot this point -4, -3. There's a point there. I think we're okay with that. The bigger issue right now is what we do next. Um, you can use the slope to draw the rest of the line. What I need you to understand though is first of all, think about a number line. Okay. If I'm on a number line and here's 0 and here's -4, we have to remember less than when it comes to the x axis, right? Less than signs always means to the left, right? Greater than means to the right. So we're saying that the x values on this line are from -4 and this way, right? They're going to the left, which means your line better be doing either this or this as it comes out of this point. Okay. Now, you can use the slope for that, but I think an easier way is just to plug in a second x value. If you have 2 points, then you can connect them and draw a line, right? So it may be easier for you to just pick a point, a number for x that's less than -4. I will choose -5, right? And this means you can plug that in again. I would get 2 times -5 plus 5, and -10 plus 5 is -5. So I have this point -5 comma -5, and that goes right here. Once you have 2 points, you can connect the points. And the question is, should I connect these with a little line segment and it stops right there, or should it have an arrow? Okay. What you need to realize is anytime your original inequality, right, this thing up here, has one inequality with one number, then that means you're going to have one endpoint right here, and you're going to have an arrow at the end of your line, right? It's going to keep going for all x's that are less than -4. So it's going to go to the left forever. The only time it's going to stop and have 2 endpoints on it is when there's an inequality that has 2 numbers in it, right? Something like this. That's when it's going to have no arrows. You have to have an arrow if there's only one inequality because it's going less than. Okay. For my second piece here, again, I'm going to plug in my endpoint. So x equals 1, which means my point is -1 minus 3, which is -4. So that means I have a point 1 comma -4. I can plot that point. Should it be open or closed? We're looking at this. It is not or equal to. It doesn't have the line underneath, so we know this is an open circle. So 1, -4 here. Again, x is greater than, so it should be moving to the right. And what I'm going to do is just pick another x that's to the right of 1. So I'm going to pick 2. If x equals 2, then y equals negative 2 minus 3, which is negative 5. So I go to 2, negative 5, plot that point. Again, I'm not just going to connect it with 2 endpoints. I'm going to draw a line through that point and put an arrow at the end because it goes for all x's bigger than 1. That means there's a point where x is 3, right? There's a point where x is 4. There's a point where x is 5, and it keeps going forever for all x's to the right. That's what's going on here. So let me show you an example of when you're going to have 2 endpoints. So here in this example, I know right away, without even doing any work, that I'm going to have 2 pieces, and they're both going to have 2 endpoints. Why? Because their inequalities, it's called a compound inequality. It's saying that x is greater than negative 5 and less than negative 2. That means there are 2 endpoints, one at this x and one at this x. That's what we're being told here. So again, I'm going to start by just finding that. So in x equals negative 5, I'm going to go ahead and plug that in. And negative 5 minus 3 is negative 8. And I know I have that point. I don't have the line underneath, so we know there's an open circle there. And then once you have this point plotted, right, so here's my open circle at negative 5, negative 8, I have another endpoint that you have to find. So x equals negative 2, which means y is going to equal negative 2 minus 3, which is negative 5. And here's my other point. So when you have these 2 points plotted, this is also an open circle. You don't have any arrows because it's saying that the only points that exist have x's that are in between these 2 endpoints, right? It's not less than and forever. It's not greater than and forever. It's just in between those. So you're going to connect these with the little line, and that's it, right? There's nothing more you can do. If this had said x is less than negative 2 only, then we would have had this open circle at negative 2 and then the line with an arrow. But it doesn't have that. It has the extra inequality saying it's in between. Okay, so now we want to look at the next point or the next line at the bottom. So this one also has 2 endpoints. First is x equals negative 2. So when x equals negative 2, I plug it in, I get negative. Remember, this negative in front is always there, and then the negative 2 goes where the x is. And a negative times a negative makes it a positive. So 2 minus 7 equals negative 5. So I have this point, negative 2, negative 5. That's the same point that was already there, so you can just kind of leave it there. This one's also an open circle, so we're good. Then I plug in x equals positive 2, which is y equals negative 2 minus 7, which equals negative 9. And our point is 2, comma, negative 9. So I have this point plotted. This one's also an open circle because there's no line at the bottom. Again, now the question is, I have these 2 points. I'm going to connect them because that's what it takes to draw a line. Should I connect them and then keep going with an arrow or just stop? You're just going to stop, right? It's just in between these values. So notice again, give me an example of a point in between these. Well, there's a point here with negative 1 point something, negative 1, negative 0.5, 0, 0.5, 1, 1.5, all the way up to 2. But it doesn't go past that, right? All of the x's are in between negative 2 and 2. And that's it, okay? You don't need to do too much here. And what I'm suggesting, I guess, is plot 2 points, connect them to draw a line. I want to show you one more example. So this guy looks a little bit different. It doesn't have any less than or greater than signs at all. It just has this or equal or not equal to symbol. And I think that's tripping some of you up as well. So here's what this means. Okay. It means that we are still going to plug in this point almost like it's an endpoint. Okay, so if I plug in x equals -5, I'm going to get -5 plus 6 is 1, and I have this point at -5, 1. The not equal to means there's an open circle there, right? So if I go to -5, 1, I'm going to have an open circle. The difference here is that's not just an endpoint. What this is saying is x exists everywhere else. So that means it should go to the right and it should go to the left. Okay, so this is going to have 2 arrows instead of 1 or instead of none, right? We've looked at each example. So what you're going to want to do is pick an x that's to the right of this value, right? So what's a number that's to the right of -5? I don't know. You could pick lots of numbers. What if you pick -2? Then when I plug it in, I'm going to get y equals -2 plus 6, which is 4. So I should have this point -2, 4, and I plot that point. Here's -2, 4, and this is saying x that this line goes on forever. So as long as x doesn't equal -5, this line exists. So should there be a point at -4 and -3 and -2 and so on? Yes, right? It keeps going forever. There's my crooked line. And it should have an arrow. But it should also go to the left. So you need to pick a point that's to the left of -5. So in this case, maybe I'll choose -6. And when I do, my line is -6 plus 6, which is 0. I have this point, -6, 0. Here it is. And I should draw a line with an arrow going that way as well. So this is a line that has all points, infinite number of x's, except -5. There's a hole in the graph right there. So then we go to the next thing, right? It says, what about when x equals -5? Y is equal to -1. So that's a point, -5, -1. It does equal, there is an actual point there. So I'm going to plot a point. And then that's it. I'm done. There's nothing else to do. So I guess what I want you to realize, maybe I can summarize this over here. Each piece is going to have a domain restriction, right? If you have x less than a number, or x less than or equal to a number, or x greater than a number, or x greater than or equal to a number. All of these situations, you're going to have a piece that, well, actually, let's do it one at a time. If you have x less than a number, you should have an open circle and a line going to the left with an arrow. For the less than or equal to, you should have a closed circle and a line going to the left with an arrow. It could be, I don't know what the slope is, but that should be happening, right? If you have x greater than, you should have an open circle with the line going to the right. And this should be a closed circle with a line going to the right. There's going to be one arrow at the end of your piece anytime you have one inequality, right? Now, what's the other scenarios? We also have situations where it says number is less than x is less than another number, right? It might be or equal to whatever. That doesn't even matter. In that case, you're going to have 0 arrows because your graph is going to be stuck between 2 points. So it's going to be a point and a line segment and another point. And it might be closed or open based on whether this is a line underneath it or not, but that's what's happening. And then the third possibility is you have something that says X not equal to a number. In this case, you should have two arrows on your line, right? It's going to be an arrow, part of the line, an open circle, and another arrow. Okay. And so I want you to keep that in mind with what your graph should look like. And I want you to plug in X values to find points and connect the points. Some of you are struggling with the slope, then forget the slope. Don't even do it that way. All you need to draw a line is 2 points. So use that to help yourself out. I hope this makes sense. Let me know if you have questions. Please, some people are reaching out. Some of you are really struggling and telling me afterwards, hey, I spent 2 hours doing my homework, or I spent 3 hours doing my homework. Send me a text message before it takes that long, right? Let me help you. I know this is hard. I hate that we're not in class, that I can't help you in person. This is really difficult stuff to do on your own. So let me help you, but I can't if I don't know how much you're struggling. Please reach out. Also today, Wednesday, May 6th, I'm going to have office hours at 3 p.m. for certain people that I've talked to. So if you want to get in on that, send me a message. All right. Have a great day.